Hey guys, welcome to my second class on calculus, in particular differential calculus, where the objectives will be to obtain the derivative of a function y equals f of x and to explore the first principle of differentiation. In my first video on calculus, we talked about the history, development, and applications of calculus. Please follow the link in the description below to get to that video. Welcome to GER Hub Mathematics and Statistics lessons. Please subscribe to the channel by clicking the subscription button below, and endeavor please to turn on your notification button. Endeavor to like, share, and comment on this video, as your useful comments are very important to the growth of our channel. Thank you very much. Now let's get to the video. So the first question we shall be answering in this video is, what is the derivative of a function y equals f of x? So simply put, the derivative of a function y equals f of x can be defined as follows. So if y is equal to f of x, what is defined as the derivative of y with respect to x is written as this and pronounced as dy dx. Repeat, dy dx. And it is defined as the limiting value as an infinitesimal change in the independent variable x tends to 0 of what is called the gradient function, change in y all over change in x. And this gives the definition of dy dx, called the derivative of the function. So what is the y dx again? It is called the derivative of the function. It is called the derivative of the function y equals f of x. How is it pronounced? It is pronounced as dy dx. I repeat, it is pronounced as dy dx, and it is defined as the limiting value as change in x, the infinitesimal change in x, the independent variable tends to 0 of what is called the gradient function. So this ratio, change in y all over change in x, is called what? It is called the gradient function. Now let's move on to the next objective of this study. Remember, the derivative of a function represented by dy dx is the limiting value as change in x and infinitesimal change in x tends to 0 of what is called the gradient function. This ratio, change in y all over change in x. Having talked about the derivative of a function y equals f of x in terms of what it means, let us now consider the first principle of differentiation, being a foremost technique that is principally anchored on the use of limits to getting derivatives of a function. Okay, so we shall start with taking the steps necessary for getting a function differentiated using the first principle of differentiation, and thereafter take concrete examples using the first principle of differentiation. So first principle of differentiation is a foremost technique that is principally anchored on the use of limits for obtaining the derivatives of a function, and I'm going to show you in several steps how to differentiate a function using the first principle of differentiation, starting with the general expression y equals f of x. So let's go into it straight away. Now, if you have a function y equals f of x, okay, if given a function y equals f of x whose derivative is sought using the first principle of differentiation, what you are going to do is to start with this, a step 1. Okay, so I'm going to start with the step 1. What should you do? For you to obtain the derivative of this function y equals f of x using the first principle of differentiation, step 1 would require you to increase the argument x by an infinitesimal change in x. So x, the independent variable or the argument, when increased by an infinitesimal change delta x or change in x, would cause a change in y, an infinitesimal change also change in y. Okay, so the infinitesimal change in x, the argument, would cause an infinitesimal change in y called change in y or delta y. Now this is the first step you have to take if you have to differentiate this function y equals f of x using the first principle of differentiation. Still in this first step, after doing this, that is increasing the argument by an infinitesimal change and consequently increasing the dependent variable y by an infinitesimal change in y, you would make this the subject of formula change in y when made the subject of formula becomes f of x plus change in x minus y. But what have we been given y to be? We have been given y to be f of x. So in place of this y, you simply put f of x. So this results in y, change in y equals f of x plus change in x minus what y is, in which case it is f of x, and that concludes step 1. Now that we have obtained change in y in step 1 to be f of x plus change in x minus f of x, that is, we've obtained change in y, the infinitesimal change in y, to be this in step 1. Let us now consider what next is to be done in step 2. In step 2, what we have to do is to obtain the gradient function. Now, the gradient function, like we discussed earlier, is change in y all over change in x. So what do we do in this step 2? Obtain the gradient function. So to obtain the gradient function, all you have to do is to divide this result, both sides of this result we obtain in step 1, by change in x. So I'm going to do this. Change in y all over change in x will be equal to f of x plus change in x minus f of x all over change in x. And this concludes step 2. So what have we done in step 2? We have obtained the gradient function change in y equals change in x. And that on the other side would give us f of x plus change in x all in bracket minus f of x all over change in x. And that concludes step 2. Now that we have obtained our results for the gradient function in step 2, all we have to do in step 3 is to get the derivative of the function. How do we get the derivative of the function? Remember, from our first subheading, we had discussed the derivative of a function to be the limiting value of the gradient function. And what have we obtained the gradient function to be? We have obtained the gradient function change in y all over change in x in step 2 to be f of x plus change in x minus f of x all over change in x. So to get the y dx in our step 3, all we have to do is to take the limiting value as change in x tends to 0 of change in y all over change in x. And that would mean the y dx is the limiting value as change in x tends to 0 of all we have obtained to be our change in y all over change in x. That is limiting value of f of x plus change in x minus f of x all over change in x. And this concludes the principle called the first principle of differentiation. We shall be using this principle to solve several problems I'm going to put forward in this particular video immediately. So let's see. Now, as an example 1, let us obtain the derivative of y equals x squared, a simple polynomial function using the FPD, the first principle of differentiation. It is very simple. So what do we have to do? Let's start with the solution. Using the steps, solution. So, step 1. What was our step 1? As we had discussed earlier on, our step 1 using the first principle of differentiation requires that we obtain change in y. That is the infinitesimal change in the dependent variable. So let's start with doing that. If y is equal to x squared, then it means that when x increases by an infinitesimal change in x, then y will consequently increase by an infinitesimal change in y. So the next thing to do is to make change in y the subject of formula, and that would mean having x plus change in x all squared minus y. But what did we get y to be, or what were we giving y to be? We were giving our y to be x squared. So in place of y, we are going to be putting x squared. Now this gives you change in x plus change in x all squared minus x squared, which is your y. Now if you expand this and simplify, you're going to have change in y equals x squared plus 2x times change in x, okay, minus plus change in x all squared minus x squared. Now obviously x squared cancels x squared, and we are left with change in y equals 2x in bracket change in x plus change in x squared. And this concludes our step 1. In step 2 of the problem, our task will be to obtain the gradient function. So all you have to do is divide what we had in step 1, that is change in y equals 2x change in x plus change in x squared. We have to divide this result by change in x. So I'm going to do this. I'm going to divide this by change in x, and this will mean dividing this side by change in x, okay? Now if you simplify, change in y over change in x would give us 2x change in x in bracket all over change in x plus change in x all squared all over change in x. And this would mean change in x cancels change in x cancels this, leaving us with one change in x. So change in y all over change in x would finally give us 2x plus change in x. And this concludes your step 2. Finally, in the step 3 of this problem, all you would have to do is to obtain the derivative. And remember, the derivative of the function y equals x squared in this case would be obtaining the limiting value of the gradient function you had obtained in step 2. So what we are going to do is to obtain the y dx. And what is the y dx? It is the limiting value as change in x tends to 0 of change in y all over change in x, the gradient function we had obtained. So this will become the limiting value of whatsoever we obtained as our change in x, change in y all over change in x. In this case, what was our change in y all over change in x? That is our gradient function. It was 2x plus change in x. Now, what this means is as change in x tends to 0, whatever component of this expression contains change in x becomes 0. So as change in x tends to 0, this becomes 0. This remains, and that would mean the limiting value as change in x tends to 0 will be 2x plus 0, giving us 2x. This implies that the y dx, using the first principle of differentiation for y equals x squared, is 2x, and that completes the differentiation process using the FPD, the first principle of differentiation for this problem. Now let's go to example 2. As another example, that is example 2, let us obtain the derivative of y equals 3x, another simple polynomial function using the FPD, the first principle of differentiation. Let's see how this is done. So I'm going to start the solution here. So as a solution to the problem, let's consider step 1 again. In step 1, we are to obtain the change in y, that is the infinitesimal change in y. So I'm going to do this. Change in y must have come from a change in x. So take note, it is not 3x that is changing, it is x that is changing, okay? So y plus change in y must have come from x plus change in x. It must have come from an infinitesimal change in x. Now, if you make change in y the subject of formula, change in y becomes 3x plus 3 times change in x minus y, okay? So I've expanded at once, and that is what change in y would give you. So if you continue simplifying the problem, the next thing you will get is this. So change in y, if you simplify further, would give you 3x plus 3 change in x, okay, putting this in bracket, minus what y is. And what was our y? It was 3x, okay? So obviously 3x minus 3x will give you 0. So change in y will be left with 3 in bracket change in x. And that concludes step 1. Immediately, let's go to step 2. In step 2, your task will be to obtain the gradient function. And how do you obtain the gradient function? All you have to do is to divide both sides of the limiting of the result you got in step 1 by changing x. So I'm going to do this. Change in y all over change in x will be equal to 3 change in x all over change in x. So if change in x cancels change in x, you're going to get your change in y all over change in x to be equal to 3. Okay? Now, that will conclude your step 2. And finally, your step 3 in this problem would now require you to obtain the limiting value as change in x tends to 0 of the gradient function, change in y all over change in x. Now, your gradient function is change in y all over change in x. So when you take the limiting value as change in x tends to 0 of the gradient function, this gives you the y dx, which we want to obtain. So I'm going to put here the y dx will be the limiting value of change in y all over change in x, and that would mean taking the limiting value of what we got for the gradient function, in this case, the constant 3. Now take note, the limiting value of a constant is a constant no matter what change in x tends to, and that means that the limiting value of 3 as change in x tends to 0 will return 3. So it means that the y dx for this problem will be 3, and that concludes our solution. Please like, share, and comment on this video, and most especially if you haven't subscribed to the channel, please click the subscription button and endeavor to turn on your notification button, and I'll be seeing you in my next video. Thank you.